Okay, hello everyone. This video I will start introduce power generation and the power distribution. So first thing, let's go review the basic properties of electricity. So energy, for the first term, energy. The electrical energy can be converted to multiple forms of energy like mechanical, lighting, heating, like thermal energy. And power is the rate of the consuming energy. So we can use the watt, W, as the energy or work. The unit is a watt or kilowatt. Power is watt-hour or kilowatt-hour by time. So energy is power by time. And the last video we introduced the direct current. So direct current is a constant flow of electricity through a conductor in one direction. A dry cell battery connected to a light bulb is an example of the simple direct current circuit. So the one thing, direct current means one direction. So let's see what's the new things in this class for the current, type of the current. It's alternating current. So the different things is direct current, that means one direction, and alternating current means reverses direction all the time at the regular interval. Let's see, so this one, if we see this one, it's usually that's alternating current. This is a symbol of the alternating current. So let's see what's detailed information for alternating current. Generators use conductors, magnetic flux, and motion to convert mechanical energy to electrical energy. And generators can be designed to deliver alternating current AC, where the electrons flow reverses direction and at regular interval. Okay, so what means this? Let's see this one, this figure. So the direction that's with the time, the direction that's change. Okay, that's a degree that's change, and also to the positive, and then go down to 0, to negative, go 0, go positive. So the direction always change with time. But for direct current, this stable, just have the one direction with the time. So this difference, direct current and alternating current. And the electrical utility use alternating current power because it can be distributed in high voltage and can easily be transformed into safer, lower voltages for building uses. So what's mean, like say the AC, with the time it can the voltage can change to high voltage, lower voltage, negative voltage, positive voltage, 0 voltage. So with the time, let's always change direction, and voltage is always changes. So that's why the electrical utility use AC power. And then we already know alternating current. Let's see power generation. So where does the electricity come from? What's mean the outlet in the wall? So how to connect outlet with electrical energy, and what's mean power lines outside my house, and what is a high voltage line, low voltage line, and what is a power company, where we can get the power from the utility. Okay, power supply sources include, like I just list some popular things: local utility, wind-driven generator, fuel cells, on-site aging generators, solar photovoltaic system. Okay, that's a very popular and common power supply source. And do you remember when we introduced the stability, we mentioned green power or renewable power. So based on last lecture, we just need to remember the five popular renewable source: solar, wind, hydropower, geothermal, biomass. Okay, There's 5 popular: green power or renewable power. And then we already know where we got the power. So we can know how to generate power. So utility companies use steam, gas, or water-driven turbines to generate electric power. Generator drives rotate 60 times each second, which causes electron flow to change direction or alternate direction. So that means the AC is rotate all the time. So with the time, each second is rotate 6 times, 6 cycle. So resulting electrical power is called 60 cycle or 60 Hertz alternating current. So rotate 6 times each second is 60 Hertz. We can say it's 60 Hertz AC. And if it's rotate 50 times each second, we can call that 50 Hertz AC. Okay. So we already know what is how to generate power. Let's see the types of the current from the power generation. So this one is 3-phase current. The high voltage transmission lines usually use 3 conductors. Utility generates 3-phase power. And 3-phase current and voltage peaks are offset 120 degrees between the 3 phases. It will result in equal electrical loads, which will lead to more continuous and balanced current flow. Okay, that's information or explanation for the 3-phase current. And then let's see what's mean of the 3-phase. So first, let's see what's a single phase. Single phase is mean one cycle only have the one phase from like this one is original point at 0 degree, 0 voltage, and then go to the positive voltage is 90, and then go back to 0 at the 180 degree, and then go the negative, and then go back to original. So this means it's one cycle from positive 0, negative 0. This total is one whole cycle for single phase. And do you remember when we call 60 Hertz AC, this means rotate 60 times each second. This at US and Canada, the electrical system is 60 Hertz AC. And for others, like in China, this rotate 50 times each second. That's 50 Hertz AC. So what is a 3-phase? 3-phase, that means have the 3 phases in the one cycle, but the direction, like the direction or voltage, there's difference. The vertical line is voltage. Okay, and that one is 0. So the phase 1, the start point right here, and then go 0, negative, go 0, positive. That's a whole cycle for phase 1. Phase 2, from negative, go to 0, go positive, go 0, negative, and go to the original point. But the phase 3, even though the original start point is same as phase 2, but the direction is different. Okay? So the total 3 phases means a 3-phase alternating current. And we know single phase and 3-phase. So where we can use 3-phase, where we can use the single phase power. For the commercial, industrial, electrical customers, use a 3-phase power to carry their electrical motor loads. So why? Because 3-phase motors are more efficient than single phase. If the motor larger than 5 horsepower, usually we use a 3-phase power. But for residential, so in the residential building, we don't need to use too much power. So we can directly, or we usually just use single phase power, that's enough. So that means three-phase power is more efficient, can provide more power, but single-phase power is less efficient, provide less power. Okay, there's a difference for single phase and three phase. And how to do calculation. So for the single phase power, P is E by I. It's same as direct current. Because single phase power is always for AC, and for DC, we also use this one. The same as DC. Okay, it's power voltage by current. For example, a single phase 120 volt device requires 20 kilowatt. Find the load current. I is P divided E. We can get the current. But for the three-phase power, it's a little bit different. Square root of 3. Okay, so I for three-phase, I is P divided E by square root of 3. This method to calculate I for three-phase power. So higher voltage, less amps, smaller conduits. You see, single phase, this one have the higher voltage. Three phase have lower voltage. Three phase have the higher. But the calculation, three phase have the lower amps, single phase have the higher amps. Okay, so that's the difference single phase and three phase. Power distribution. So why we need AC power? So AC power can be transmitted over long distance without large distribution losses. And AC power can be transmitted in high voltage and then transformed to lower voltage at the customer service entry. Do you remember? Again, alternating, the voltage it changes with the time. So if we want to use high voltage, we can pick up some time when the alternating current at the high voltage, and also we can pick up the lower one. Okay, this means the AC always change, the voltage always change. So AC power, it should be better to use to do power distribution. And very high voltage, up to 500,000 volts, are used on major distribution line because higher voltage means less current, and with less current means less transmission losses. So in the transmission line, we need a high voltage electric. So this is a power transmission line. This area is very dangerous, so don't work close to this area. And then let's see what is power generation and transmission line in the power distribution. So first station, that's generating station. Okay, that's produce supply or supply power. And then we need to, do you remember, during deliver or transmit power, we need high voltage. So we use transformer to deliver higher voltage. So now we have the high voltage in the transmission line. And before delivered to the customers, like a residential building or commercial building, we need step down transformer. We need lower voltage, high voltage. So we need transformer again, but this one is step down. So this is power generation and transmission. First, generation station, step up transformer, transmission line, and then step down transformer go to customers. And what is transformer? So this example for step down transformers. We know we have the primary and secondary. So primary voltage is higher and secondary voltage is lower because it's step down transformer. That means go transmission line right here, and then step down transformer, and then go to customer. Okay, go to this customer. So that's the one. This transformer, this high voltage, is lower voltage. So let's see. The reduction into the secondary voltage is proportional to the ratio of windings from the primary to the secondary voltage. So that's one, ratio of windings we can directly find from the transformer, this given information. So for example, the 50 to 10 or 5 to 1. This from primary, secondary. So when we calculate the voltage, we can see, let's say VP, V primary, V secondary, okay? Divide 5 equal secondary voltage. But what is current? Current should be reversed. So current IP by 5 is IS secondary. Okay, that's a difference for voltage and current. As for step down transformer, let's see other example. So find the transformer capacity and the secondary voltage and secondary current for a residential single phase transformer. So we know the VP VI, and then residential is 55. So we can know VP divided 55 is VS. VI by 55 is, oh sorry, this IP, not VI, is IP, primary current IP. Okay. IP is IS, the secondary current. There's a formula to calculate the secondary voltage and the secondary current. And then for the power distribution, we need to consider power factor. This is related to or in age caused by inductance or capacity. So what's mean this? The transformers, motors, and the ballast includes windings, and all windings have a property called inductance. Inductive resistance is a term which describes the tendency to resist changes in current flow. So it's a characteristic of windings in AC circuit, which result in delayed current flow. So the current peak occurs after the voltage peak. So we also can call it a lagging current. Lagging current means lower metered and less income to utility company. So when we calculate the power used, we have to consider power factor. So here is a regular one. We can see the peak current in this area, peak voltage in this area. It's happen at the same time. It's in phase AC circuit and regular one. We also can parallel resistive. But for one-way capacitor and inductor include, so what happened? Like in this one, there's a current less voltage. The peak of the current happens before the peak of voltage. This current less voltage. If it's an inductor include in the circuit, the current lags behind peak of voltage. You see? So in this case, we can see the lagging. Okay, if the lagging happens, how to calculate the power use? So power factor is a method to calculate the real power. Power factor is the number index used to quantify the lagging current. A building with no motels or coils will have a power factor of 1. That means no lag. If lag happens, how to calculate? Building with substantial motel loads and ballasted lighting loads will have a power factor of less than 1. So let's example. Calculate the overall power factor for a building if the connected loads are 50, resistive loads with a power factor is 1, 40% lighting with a power factor is 0.6, and 20 electrical motors with a power factor of the 0.8. So that means the total power have the 40 resistive, 40 lighting, 20 electric, and this one power factor is 1. This one power factor is 0.6. This one that's 0.8. So when we calculate the total power factor, we have to consider this means it's total power factor. So once we want to calculate the total power, we can use the power factor to by the exist power. So let's see how to do calculation. The power formulas for alternating current circuit. So the Watt's law formula for DC for direct current circuits also apply to single-phase AC circuit containing only resistance. So if the lagging current happens, so how to do calculate? So original one is P is I by E. If the power factor included in the circuit, we adjust by the power factor, we can get the real power usage. And the single phase AC, here is example, a single phase AC circuit draws 9A from a 120V source. If the power factor is 60%, what is the power rating in watt? So just use this formula. P is, I think this one should be 9A. Okay, current is 9A, E is 120V, and then power factor is 0.6. So we can get the power. And then what happened for three-phase? So three-phase a little bit different is we have to consider this one. Do you remember for the regular three-phase AC, P is I by E by square root of 3. Square root of 3 is also 1.73. Okay, it's about this. So we can directly use this number. Okay, so when we have to consider power factor for power calculation, we just need to add power factor in this formula. So for example, what is the power rating in watts of the three-phase circuit that draws a 15A from a 120V source if the power factor is 70? So I 15, E 120, PF power factor 0.7, and then this constant. We can get the power usage. Okay, now we already know where we can get power, we know how to do power distribution, and other essential components for the power distribution is grounding system. So grounding is a safety mechanism that connects part of the electrical system to ground, providing a safe path for electrical current to return to the ground in case of the fault, like such as a short circuit. Short circuit is very dangerous, so we have to avoid it. That means the resistance is very low. That's cause the current very high. So it's very dangerous for equipment and users. So There have the two types of the grounding system. First one is system grounding. This is used in power generation and distribution. And system grounding involves grounding the neutral point of the transformers or generator. So what means this? Let's say the first station generating station, okay, and then connect to consumer. So this one have the transmission line, okay. So the generating station, we have to consider grounding. In transmission line, we also need to consider grounding. So this type belongs to system grounding. And equipment grounding, the type of grounding connects the metal frame of the electrical device or appliance to the ground, ensuring that any stray currents are safely directed away from users. So in the like a residential building, commercial building, we also need to consider grounding system. Okay, we also need to consider grounding system to release the electric. So how the grounding works? So we can say this is an electrical system, and then the green line usually is a ground line, and then we need a ground rod to connect to the grounding to relay the electric. So in a grounded electrical system, certain parts of the wiring or components are connected to a ground rod or ground plate buried in the earth. The connection to the earth provides a low resistance path for fault currents to flow into the ground safely, instead of passing through people or equipment. So that's a grounding system. So next one is for residential electrical system. So now we already got the electric power from the generating station and delivered it through the transmission line. So now we already got the power in our home. So what is a residential electrical system? Usually most of the building we use 120 V AC power. This provided to a duplex outlet at 60 Hz AC. And the hot plate is connected to the black conductor carrying the 150 to 120 V. So we can say that one is a hot plate. This large is smaller. So we can say the plug-in, we can say that it's larger is smaller. So this one is hot, and then this one is hot line. And the neutral blade is connected to a white conductor that provides a complete circuit for electron flow. So this one is neutral. This is a neutral line. And this one is green. This connect to green ground. So this is a grounding system. The current is equal in the hot and neutral wells, but the voltage in the neutral is minimal. And the ground opening is connected to a ground conductor. In residential, is typically an uninsulated well. So we can see the outlet. We have the ground line, neutral line, hot line. And also the plug-in have the neutral and hot. And this one, ground line, will connect to the ground. Okay, this is a component for the outlet and plug-in. And what is the voltage for the appliance in the residential building? So most of the appliance we use 120, but some appliance we use 240. So what is the appliance? Which appliance they use 240? Dryer, oven, hot water heater, only electric. So only electric. And the central air conditioning. usually they are using the 240 volt. And then last one, it's about the homework. So we already know how to distribute and generate power, and then how to deliver the power in our home or in our building. So what is the appliance they are using power? So this homework, let's see the information. Complete the following table where appliance by obtaining the information from your home, just one location. So you can just choose one location, like your home or apartment you are living now. Just choose one location, and then to see what appliance you are using in this home, in this location, and record value from nameplate using you can use a black color pen, and then record the calculated value in red color. So just try to use a different color to record the value from nameplate and record the calculated value. So what's mean? For example, this is a mixer, is blender. So we can write the Hampton blah blah. So you can write the MAC in the MAC area, and then we can see the voltage is 120 V, 60 Hertz, and power is 900. So we can calculate. We can use the black one. We can use a black one to calculate power is, and then you have to switch red pen to calculate what is the current. Okay, because this one you cannot directly find from nameplate, you have to calculate it. And also to complete the others. If you don't have this, that's okay. So just make sure you find appliance from your home and put number and MAC right here. If you find others, you can use the blank area to record the value. And then here is the example. You can see black one is record value from the nameplate. Red one I just record calculated value. And finally, you have to calculate the total current and power. So this one, what is 120? It's a V. Okay. Do you remember some appliance is 120 V, some appliance is 240 V. So you have to separate to calculate the total current and power. For example, for the 240 V, you can see that's one and that's one. So just the plus 80.75 and 24 to calculate the total current for appliance with 240, and others like that's plus and others to calculate the appliance total current for the appliance with 120 V. Okay, and the same as the power. So finally, one more thing, like for the 120 V, you see like a refrigerator, the V is 115. So that's okay, you can just add this as a 120 because they're similar. So just plus them. And finally, you can check your answer that's correct or not. Like I is P divide E. So you already calculate like 120 appliance with 120 V. The power is 8340. So the V is 120. You can directly use the power divide E to get the I, and then to see the number is same as this or not. If it's same, it's correct. If it's not, you have to calculate again to check your answer. So this is